Hi, so the problem that I was assigned was number 2 from the test, and it just says find the dimensions of a rectangle with a perimeter of 64 meters whose area is as large as possible. And so the first thing that I start off doing, you can draw just like a rectangle so you can visualize it, and do one side is X and then the other side is Y. And because it's a rectangle, you know that because this is X, this will also be X, and because this is Y, this will also be Y. And then the problem gives you that the perimeter is equal to 64 meters. So you can write that down. And then from prior knowledge, you should know that the perimeter of a rectangle, you just add up all the sides of the perimeter. So you can write the equation for that. So you can write P is equal to 2x plus y. And then I wrote 2x plus y because there's 2 x's and there's 2 y's. And so then with this, since you know the P is 64 meters, you can then plug in 64 for P and write that out, and you should get 64 is equal to 2 2x plus y. And then you can divide this by 2, so you get 32 is equal to x plus y. And then at this point you can choose whether to solve for x or for y, but I am going to choose to solve for x. So you should get x is equal to 32 minus y. And then from here, you can start to think about, it's asking for the area that's as large as possible. And so again, because it's a rectangle, you know that the area of a rectangle should be length times width, or in this case, x times y. And so then, because you know the area of a rectangle is x times y, you can then write a in terms of x, because you just solved for x. So you do a of x is equal to, and then x is equal to 32 minus y, so you plug that in for x, times this y right here. And so if you distribute the y, you should get a of x is equal to 32y minus y squared. So now you have a function for a of x, which is the area. And because you want the area as large as possible, we need to take the derivative of this area. So we do a prime is equal to 32 minus 2y. And that's the derivative of a of x. And so then, again, because you want the area as large as possible, you set the derivative equal to 0. So it's 32 minus 2y equal to 0. And you solve for y. So it should be 32 is equal to 2y. You should get y is equal to 16. And because you have now found y, that's right here and right here, based on this equation, you can find x. And so you just plug in the y. So x should be equal to 32 minus 16. And then you should get x is equal to 16. So we have now found x and y. So these are both 16, and this is both 16. And you know that the area it asks for the dimensions of the area that's largest possible. So you would then have to write, because it's dimensions, 16 meters by 16 meters. Because that's x by y. Because it's a is equal x times y. And that should be your answer. Let's just box that. And there you go. Thank you.